Now we're going to address the current in a parallel circuit, which relates to Kirchhoff's junction theorem, which tells us the sum of the currents entering a junction is equal to the sum of the currents leaving a junction. Now when we last addressed this theorem, it was with a series circuit which has no junctions. So we found that in a series circuit we have the same amount of current through the entire circuit. But with a parallel circuit we have junctions. We have multiple paths that the current can travel on. I'll draw a simple parallel circuit with 3 resistors, and since we have 3 different loops, there are 3 possible pathways that the current can take. And when we talked about the loop rules, we addressed that. So if we take a look here, we have one loop going through resistor 1, one loop going through resistor 2, and one loop going through resistor 3. So if we go back to our analogy of the ski lift, we have a lot of people leaving the lift, and we can relate that to our total current. But if we have 3 different pathways down the hill to get back to the lift, some of the people are going to go on the Black Diamond Hill. Some of the people might take a medium difficulty route, and some people are going to go down the easiest hill that they can find. Or maybe these are 3 equally different hills, or difficult hills, but they're different, so sometimes people choose the one that has the least amount of people on it. Whichever the case may be, not every person that gets off of this ski lift can go down every hill at the same time, so they split. The total current coming out of the battery equals the current total on all the paths at that junction. So the junction splits and the people can go 3 different ways. The current can go down 3 different paths. You add up those 3 currents and you get the total. There are a couple different analogies you can make to this same idea. If you think about Route 79 going south into Pittsburgh, you're traveling along Route 79 and there's a split. You can go to 79 or you can continue on Route 79, but the cars can't go both ways at the same time. You have some cars going one way, some cars going the other. That would be like the total current, and then the current through resistor 1 and the current through resistor 2. So the total current is equal to, in this case, the current through resistor 1 and the current through resistor 2. Or similarly, if you think of water flowing downhill, and there's 2 possible ways for that to go, over a less steep incline or a complete vertical drop, it all ends up at the bottom, just like it all ends up back at the battery, but it took 2 different routes to get there.